Hello and welcome to I'd like to say brief, but it may take us a little bit of time to get through it, tutorial on a function in Excel, or a series of functions in Excel that are very powerful, but not used as much as I think they should be. Specifically, I want to talk to you guys about database functions. So to jump in, first thing I want to start with is, even though we call these database functions, you should never use Excel as an actual database. There are programs for databases. Excel is not that thing. There are a lot of reasons why Excel would not be good use as a database. However, I know a lot of people do, but you shouldn't. That being said, let's see what database functions do for us. So what you're looking at in this worksheet is a data set of homes that are for sale in a specific neighborhood. So here's the subdivision, there are the addresses, there's the size of them and what they're selling for. That's what we're seeing. So say, for example, I was interested in knowing the average cost of homes that are selling in, say, the Windsor subdivision. Or say I'm interested in the total number of homes that are selling in the Royal Oak subdivision, right? So there's a bunch of homes here, all the different subdivisions. Maybe I want to know how many are for sale in that neighborhood. So yes, there are some functions that we know, or maybe you know, that could do some of those things for you, like average if or count if. However, what if I started adding criterion? What if I was looking to know the number of homes in the Royal Oak subdivision that have at least 2 bedrooms and at least 2 bathrooms and say have gas heat? Well, all of a sudden that's not as easy to do. Could you do it with average ifs, IFS? Yep, you could. However, there are a couple other functions out there that might make it more interesting and give you more versatility if you wanted to do some EDA, exploratory data analysis, meaning you want to change the criteria very quickly and see how the results come back. Okay, so could you use average IFS or could you use count IFS? Yeah, you could for some of these. The trick with those is it's not always easy, depending on the structure of your notebook, to change the criterion and see what the results would be. So enter what we will call database functions. So database functions are pretty handy, and what makes them interesting is, as I flip back over, all you have to do is take basic aggregate functions like sum, min, max, and count, put a D in front of them, and they become dsum, dmax, dmin, dcount, daverage, short for database. So I want to show you the structure of this function, show you how to set it up, show you how to use it, and why it's powerful. And there, as I showed you before, there are several of these. So since there are so many of these, what you'll see is that once you learn how to do one of them, you kind of know how to do all of them, right? So once you learn how to drive a car, you can drive any car. Same thing holds true with database functions. Once you learn how to do one, you can kind of do them all. So that's what we're going to talk about today. So let's jump in and I'll show you the structure first. So the database functions, all of them, doesn't matter which one, dmin, dmax, dsum, dcount, have 3 required arguments. First, you have to have the database range, which I'll show you what that is. Then you'll have to have the field name. Then you'll have to have the criteria range. And on your LMS, you'll find this sample file if you want to work along with it. And if you happen to just pop in and you're watching this video just for the kicks, out there are a ton of sample data sets you could use to apply database functions to. I'm just going to jump over to dsum. All right, so here's our entire database, and let's say we're interested in knowing the total value of all the homes in the Royal Oak subdivision. So when you set up database functions, you have to do something different. You have to have a criteria area where you clearly and explicitly define the criteria that you are searching for inside the data set. So I'm gonna do the long way first, and then I'll show you how to do it a shorter way in a minute. So I'm gonna grab this whole series here. I'm going to paste it up here. Now, a quick reminder, hopefully you remember this, but if not, let's talk about structured data for a second. So in order to use a database function, you have to have structured data, specifically tabular structured data. So if you don't remember what that means, let me run you through that really quickly for a second. So tabular data, or data that's in a table form. Structured data tables have fields. Fields have values. And a group of related field values is a record. And that's what we're looking at here. So let me show it to you, right? Tables have fields. So Address is a field, subdivision a field, bedroom is a field, bath is a field. Okay. Fields have values. So a value of the subdivision field would be Windsor or Long Lakes or Royal Oak. And a group of related field values is a record. So that's a record. That's a record. All of these are records. So as long as your data is organized in that way, you will be able to use database functions. So let's just jump right in. So let's say we want to look at all homes total values in the Heathwood subdivision. So I'm going to drop my selector cell up here in B5. And I'm going to leave something off so you can see how this works. And then I'll go back in and make it work really well for you. So we're going to open up with dsum. First thing you have to do is select your entire data set, right? So that's including the column headings. So I'm going to select this and grab all of these. I'm going to use Control-Shift-Enter to select that very quickly. So we've added our database values, right? So the first argument of the dsum function is database. Database. The database is the entire tabular data set, including the field values. The second argument we need to add is field. The field is specifically the field that has the value that you want to do something to. Add up, average, count, whatever. So in this particular case, the field of interest is cost because that contains the values that we want to aggregate in some way. So the field argument in a database function is the field, just the field, not the whole column, that you want to aggregate. So notice I selected I-17, not the entire column. The last thing we need to do is give it the criteria or criterion that we want to filter by. And in this case, what I'm going to do, and I'll show you why in just a minute, is I'm going to select the entire column here that we copied and pasted, and then I'm going to go one row down. Now that's not always going to be true, but for this one, we're going to do it. Okay. So I'm going to select, close that off. It's going to give me a number. Specifically, it gives me 3,891,500,000. Now, at first glimpse, it seems like maybe I got something. However, it's not actually the number that we wanted. Now, how do I know that? Well, let's look. So if I jump to the bottom of my data set and I just add up the cost field, you'll see that the cost field adds up to 3,891,500. That's not what we were looking for. So the function that we just created right now tells us the total value of all of the homes in our data set, not the total value of the homes in the Heathwood subdivision. The reason it did that is because I never told it what I wanted to filter by. So remember when I set this up, I took all of these that I copied and I said, hey, we have to make this criteria area. Then underneath it, I gave it a row, but that row is blank. So think of that like leaving the water running or leaving the gate open to your fence, right? So it's going to actually count everything or sum everything because I never told it what I wanted to sum it by. So what I'm going to do is I'll go to subdivision and now I can use this sort of like a database. So all I have to do is type in Heathwood and now we get what we're looking for. So when I type in Heathwood, it says, hey, 700,000 is the total value of all the homes for sale in the Heathwood subdivision. And now watch what we can do here. Check this out. So I can then change it and say, hey, well, what if I was interested in Royal Oak? 1.2 million for Royal Oak. What if I was interested in Windsor? 989,000 for Windsor, right? So all of a sudden I can use this like a database. So not only can I aggregate and get a number like I could with a sum if, for example, I can also use it for EDA, exploratory data analysis. So if I want to very quickly look through this data set and see how they're all sort of comparing, it's almost like using a pivot table if you're familiar with what that is. Now here's where it gets really cool. I can start adding criterion. So what if I was interested in homes in the Windsor subdivision that have exactly 2 bedrooms? Now that is exactly 2 bedrooms. What if I wanted exactly 2 bedrooms and 1 bathroom? All right. What if I wanted solar heat? There are none. Okay. So now what does this tell you? So it's saying in our current data set, in the Windsor subdivision, if we were looking for a home with 2 bedrooms, 1 bathroom, and solar heat, you know what? There aren't any. And that's what it's telling me. But what if I went from solar heat to gas heat? There are also none. So what if I went to oil heat? There are also none there as well. Interesting. What else do we have? Electric heat. There we go. So we have electric heat. See what we're learning from our data set? That's the value of what you can do with database functions. So let's add to that a little bit. Let's talk about the criterion. So you can use comparison operators when you're entering in criterion for a database function. So as of right now, because I don't have anything in here other than a number, it's looking for an exact match. So it's saying exactly 2 bedrooms or exactly 1 bathroom. However, what I can do is I can add comparison operators here, and I could say I'm looking for more than 1 bathroom or more than 1 bedroom. So I can do it that way. Or I could say I want less than 5 bedrooms, and I can do it that way. So you have the ability to add comparison operators to specifically your criterion selection of this data set. Now let's look at this a little bit more. What if, and we'll just take this and we'll move it down. Actually, I'll show you a shortcut here. So for the next part that we're looking at, we're just looking for homes that have solar or oil heat. Okay, so we're only going to use the criterion of heat here, right? That's the only thing we're looking at. So instead of me copying all of these column headings, I'm simply going to copy the first one, which is heat. So I'm going to grab this and paste this right here. And what I want to do next is I'm going to need to enter in criterion for solar or oil heat. Now that's where it gets tricky, right? So the reason it gets tricky is instead of having 1 criteria, we have 2 for the type of heat. Because notice in the data set, we have oil, gas, solar, and electric. But all we're looking for is the total value of homes that are solar or oil. So the way that you set that up is we are going to go solar, then we're going to go down 1 row for oil. So the lesson in that is that if you have multiple criteria in the same category, you simply add a row to your criteria selection options here. So now I can jump in and go dsum, grab my entire database, grab my field that I want to aggregate, which is going to be cost, and grab my criteria, which is going to be heat and solar oil, like so. Voila, and you got it. All right, let's move on, see what else we can do. Let's look at d-average. So remember what we said before? We said that all you have to do to take basic aggregate functions and make them database functions is you simply put a d in front of it, right? So there's a d-average function. The d-average function does exactly what the average function does. It just does it with specific criterion that you set up using the database function. And in this particular example, we want to look for homes in the Royal Oak and Windsor subdivision. I'm going to throw out a little thing that could throw you off. This says Royal Oaks here, but it's actually Royal Oak, like so. However, I've got a little trick to show you that might help you with that. Okay, so we're going to pop up and we're going to grab our subdivision. We're going to make that our criterion, and we're going to type in Royal Oak, like so. All we have to do now is instead of typing dsum, we're going to go d-average. We're going to grab our entire database. We're going to then grab our field. The field that we want to aggregate is going to be cost. And we're going to grab our criteria, which is going to be subdivision Royal Oak. And we are going to close that off. And we get 152,500 average cost for a house. Wouldn't it be nice for homes to actually cost that now? Maybe if you were buying a condo. So let's talk about Royal Oaks up here versus Royal Oak down here. And I'll show you a little trick that you can do. If you were unsure, okay, if you were unsure, you could always just type Royal Oak, like so. You should also be able to type Royal Oak, like so. So there are a couple different things we can do here. Let's see. Specifically, I want to talk to you about wildcards. There we go. So let's talk about wildcards for a second. So wildcard. So in Excel, one of the wildcards you can use is the asterisk. And what the asterisk will do for you is if you're not exactly sure how something works or how something is spelled, you can use an asterisk as a wildcard to allow it to let anything through that would match that criteria. So for example, if I thought maybe this is Royal Oaks with an S, but I'm not 100% sure, know that it always does an exact match. So for example, if I type Royal Oaks like so, see how it told me 0? It's telling me 0, and that's divided by 0, meaning it didn't find anything, because there is no Royal Oaks in this data set. But if you were unsure and you wanted to make it a little bit foolproof, what you could do is simply add a wildcard to the end, and all of a sudden everything's good. So what that wildcard's going to do is it's going to look for everything that's Royal Oak, and as long as it sees the words Royal Oak, it's going to pass that through. Everything's all good. If there happens to be a Royal Oak and there's an S at the end, it won't matter. It's just going to look for Royal Oak, and that's it. Okay, so wildcards are really helpful. So we've got one more, and then we'll get you out of here. I'm going to skip to this one. This one's specifically interesting here. So there's a couple things here that I want to point out. First of all, we're doing D count. Okay. So first thing you want to look at is it's asking for the number of homes for sale that are between 150 and 200,000. Whenever we're doing counting, remember, if you were using the regular count function in Excel, you cannot count words. So we couldn't count the subdivision column, right? We couldn't use this as the field to aggregate if you're just using D count, because it is words. Okay. So remember how we count words. If we were trying to count something that had words, instead of using count, we would use the function count A, short for like count alpha or count anything, right? It's count any cell in a range of cells that are not null. There is also a D count A. So if you're trying to count a column that has words in it, it will return 0 if you use D count. If you're trying to count it and you have words, you would want to use D count A. So let's work on that. So it's looking for the number of homes total in this entire data set that have between 150 and 200,000 inclusive. Okay. So let's see what that's worth. So when I say have, I mean cost. So we're going to take our cost field. And this is where it's going to get interesting, right? We're going to add cost again, just like that. And we'll talk about why that is. Okay. So, and just to make it more interesting, let's do this. I'm going to add one extra thing. We're going to add heat. And we'll do 2 birds with 1 stone. So the first thing I'm going to do is I'm going to do D count A instead of D count. And I'll show you why one more time. So I'm going to select my entire data set. I'm going to take my field, which is going to be subdivision, because we want to count the number of homes in our data set. That's okay because we use D count A, right? If we use D count, this would return 0 because you can't count words. Last thing we're going to do is we're going to give it criteria. In our criteria this time, I'm going to grab all 3 of these, and I'll show you what that does and how that's going to be different. Actually, I'm going to make it even more interesting. Well, let's do this one first, and then we'll change it. So the first thing you'll see that's different from what we did before is that we've got cost, and then we've got another field called cost right next to it. Why did I do that? Well, it's because of how we're going to do between, right? So we're wanting to do between 150,000 and 200,000. Well, in order to understand why I did cost and cost, and I don't want to confuse you, so let's delete that. Okay, is because Excel reads like you do, left to right, top to bottom. So if I did this, greater than or equal to 150,000, and then I did this, less than or equal to $200,000, it's not going to actually do what you think. So when you look at it, you feel like, hey, if I just add a second row of criteria, that should give me the between. It doesn't. It reads each line left to right, top to bottom. So it's going to do them like ands. And if you do it this way, what's going to happen is you're going to actually get every number before $150,000 and every number after $200,000. So you're actually going to end up getting all the numbers, like the whole thing, instead of what you were looking for. So if you need to do a between, which is what you're having here, and it's between inclusive, I'm going to need to take this criterion that you see here, and they need to be in the same line because Excel reads it all as one line, left to right, top to bottom. So it's going to go greater than 150,000 and less than 200,000. If you do down at the bottom, it'll treat it more like an or, right? So it'll give me this or this. Okay, so let's do that first, and then let's go back. Actually, we already did it, right? So there's 7. And I want to show you one other thing, and then we'll call it a day because this video is getting long. So I want to show you what to do if you wanted to have multiple criteria on here. So what if I wanted to see between 150 and 200,000 that are oil heat or gas heat? So if you look at this, first thing we would need to do is change our criteria, which we just did there. How would you read this? So some people get confused here and they would look at it and say, all right, well, this is going to be all the homes between 150 and 200,000 that are oil, and all the homes between 150,000 and 200,000 that are gas. That's actually not what's going to happen. Remember, Excel reads left to right, top to bottom, and it doesn't associate these two rows together. So what's going to happen is it's going to give you 150 to 200,000 homes that have oil gas in every home that has gas heat. Not every home between 150,000 and 200 that has gas heat. Left to right, top to bottom, not associated between rows. So what we're going to do is we're going to grab these two. We're going to copy and we're going to paste them in, and that gives us what we're looking for. All right, my friends. So there are extra practice problems on here that should be open and available for you in your LMS, hopefully. If not, feel free to refer to your book or just a quick Google search, and you can find all kinds of data sets that you can use when working with database functions. So with that, my friends, have a good day, no matter what time of day it is, and we will talk to you soon.